This lecture is on the topic of amortization. So if you've never heard that word before, it's actually just the process of repaying a long-term loan. So some common examples are mortgage or school loan, if you used a loan to purchase a car. Anytime you take out a large sum of money and then you slowly repay it over time, that process is called amortization. Okay, hopefully you've watched the video on the present value of annuities, which precedes this video, because amortization is actually just one application of the present value of annuities. So let's look back at what the present value of an annuity is. That's a situation where you give the bank a large lump sum of money, that's the present value with which you purchase the annuity, and then they slowly repay it to you by giving you little bits of payments. This usually occurs if you're in retirement or something like that and you've saved up a nest egg, then you use that nest egg to purchase an annuity, and then you slowly receive payments month by month after you don't have a job anymore, and then you just get those payments regularly. Okay, so let's just think about this the other way around. Instead of you giving the bank a large lump sum, what's more common earlier in life is that you need a large lump sum. So you go to the bank and the bank gives you a large lump sum of money, and then you're stuck in the situation of slowly having to pay it back to them. Okay, so that's called amortization. Now if we look over here at the amortization formula, you're going to notice that this is the exact same formula as the present value of an ordinary annuity. Okay, nothing's different about this formula except for the fact that I've solved it for R, which is the amount of each regular payment, as opposed to solving it for A, which represents the large lump sum known as the present value, or also sometimes called the principal. Okay, so this is solved for R, the amount for each regular payment. And you may notice that amortization assumes that the payments are going to occur at the end of each period because we're using the present value equation for an ordinary annuity. We will not go into detail on amortizing at the beginning with payments at the beginning of the period, so we're just going to stick to using the ordinary annuity. Okay, so let's get started with some examples. So this first example, I'm going to say that I have a college loan. And let's say that I took out a college loan of $15,000, and now I wish to pay it back, and I've made a goal for myself to pay it back within 11 years. Okay, so for example, here's my college loan of $15,000, and I want to pay it back over 11 years. And then I have to give you the stipulations of the loan, which is to say that it was loaned at a rate of 4.3% compounded quarterly. And keep in mind that just the same as, quarterly, just the same as annuities, the periodicity of the compounding, in this case quarterly, must be exactly the same as the period of the payments back. Okay, so if it's compounded quarterly, I have to pay it back quarterly, monthly would match monthly, etc. Okay, so I'm going to be making these payments quarterly, and the question is, how much is each quarterly payment? Notice I'm going to just write how much is each payment, but I know that if it was compounding quarterly, it has to be a quarterly payment to match. Okay, so we're just going to take this equation right here, and we're going to plug in everything we know, and go ahead and try it out yourself. You definitely want to get as much hands-on experience as you can. Okay, and R is the thing that we're solving for, and $15,000, that's the present value or principal as sometimes referred to. And then the periodic interest rate goes in here, and don't forget to take the APR and divide it by the number of compounding periods per year. Okay, and then when you raise it up to the negative nth power, just the same as before, n represents the number of periods. Okay, so that's 11 years multiplied by 4 times a year, and so that's what I'm going to raise it to, is a negative 44. Alright, so hopefully that matches the setup that you had on your page. And go ahead and make sure that you can also crunch that number out, and you should get $429.66. Okay? So that means that you're going to have to pay a little over $400 every quarter for 11 years, and then you will have amortized your loan. Alright, so whenever we talk about amortizing a loan, a very popular question is, how much money are we actually paying the loan, and how much interest did we pay? Okay, of course I'm going to have to pay back a little more than the $15,000 I borrowed, but how much more do I have to pay back? So the question is, how much interest was paid over the lifetime of the loan? Okay? Now I haven't told you how to do this yet, but I would definitely wonder if you can do it already just from what you've learned in financial mathematics. So go ahead and just jump right in and try to answer this question next. How much interest is paid on the lifetime of this loan? Okay, so the general method there is that you're going to say, well, the money in that I have to money paid back was $429.66 multiplied by 44 pay periods. That's the same 44 as the N right here, okay? And then the original loan, which is sometimes referred to as the principal, that was at $15,000. Okay, so I'm going to subtract that away from a total payment that I actually made of $18,905.04, okay? And then I'm going to subtract off the $15,000 that was actually loaned to me, and then you're going to see in the end you had to pay an extra, this is the interest paid, an extra $3,905.04 was paid, and that's just the charge for having borrowed that amount of money for that amount of time. Okay, very interesting. Let's try another one here. Now this one, the last example I showed you, we solved out for the amount of each payment. So sometimes you're in a situation where you already know how much you can afford on each payment. Like for example, maybe you're living in an apartment right now and you're at a point in your life where you think maybe instead of paying that money to a landlord, I should be paying that money back to myself by purchasing a piece of real estate, living there, and then repaying a loan. Okay? So let's look at an example like that where I already know what I can afford because I'm already inside an apartment and I'm paying $1,400 per month. So I know I can afford $1,400 per month. The question is that if I found an appropriate mortgage, how much could I borrow on a 30-year mortgage? Let's say I looked up a 30-year mortgage, and the deal with that was it was compounding at 6% compounded monthly. Okay, so that means that I have to pay a certain amount for 30 years in a row at 6%. What is the amount of money that I could actually afford? Then I could start shopping for a house. Now you saw over here I represented the amortization formula as the present value of an annuity solved out for R. In this case, it says how much could I borrow? And so the unknown here is not the R. The unknown is actually the principal A. So we can always fall back on the original formulation for the present value of an ordinary annuity. And that one is already solved for A. So that's why right now I'd rather use the one where I've already solved it for A. And I'm going to go back to my notes and see what's my equation for the present value of an ordinary annuity. And that is R, 1 minus 1 plus the periodic interest rate, raised to the number of payments, negative number of payments. Here that's 30 years times 12 times a year, divided out by the periodic interest rate just like that. Okay? So that's what you have right there. And let me rewrite it on this board a little bit simplified where I've calculated the actual periodic interest rate and the actual N. So my lump sum that I can borrow, my principal amount, is equal to whatever comes out of this equation right here, 0.005. Okay? So then I'm just going to crunch through that, and I'm going to see that I have $233,000, 508.26 cents. So that is the principal. It is often referred to in the guise of a loan as the principal instead of the present value, and that's how much I could borrow. Okay? So let's say I went around shopping for a house, but the house that I wanted to buy is I want to buy a $275,000 home. Okay, and I can only afford to borrow $233,000. So the question is, how much money do I need for the down payment? And this isn't a very complicated question, but definitely just try it out. how much do I need for down payment? No tricks here. What do you think you're going to do to answer the question? That's right, you're just going to take the difference, okay? So the cost is $275, I can only borrow $233, so you just take the difference between those two things, $275,000 minus the amount that you can borrow, and you're going to get that you need $41,491.74 for a down payment, okay? Keep in mind that if you are in the market for purchasing a home, it's typical to have to required to put down about 10 or even 20% of the actual cost of the home. In this case, 10% of this would be $27,000, so you definitely need to already have some savings ready to go, liquid cash, in addition to taking out the mortgage. Okay? So that's a good question to answer right there, but of course the main burning question is if I actually went through with this loan, how much money would I pay back? You saw me do that on the last question, and I'm going to do that again. So go ahead and work with me on this. Calculate how much interest is paid over the lifetime of this loan. Okay, this is a very common question, definitely one that you want to keep in mind before jumping into this deal. Alright, so let's see. Well, I'm paying $1,400. How many times am I paying that? 360 times. 12 times a year for 30 years. How much money did I actually pay? $504,000. That's how much money you're going to end up paying altogether to amortize this loan, okay? So let's just subtract off the principal there. The principal amount that we borrowed is $233,508 and 26. When you subtract that off, you'd be surprised to find that the amount of money that you're going to pay in interest on that loan is actually more than the amount of money that you borrowed on the loan, okay? This is incredible. This is 116% of the principal. Okay, and that's not to say that you only paid 16% in interest. What I'm saying is the interest itself is over 100% of the principal. You're paying back more in interest than you actually borrowed in the first place. You end up spending enough for a whole second home, just in the interest. That's why banks like to give mortgages. And just be aware, be very aware of the type of deal that you're getting into, because that's what ends up happening. Okay, so speaking of which, let's get another equation going here so we can delve further into the way which loans are paid back. Let's say you start a 30-year mortgage, but maybe after 10 or 15 years, or maybe after even 5 years, maybe that house isn't working out for you. And so you just end up paying the mortgage a little bit, but then you never fully pay it back. Okay, so here's another equation that's really useful. It's called the unpaid balance equation. Unpaid balance, or outstanding balance, some people call it that. Or some people call it payoff amount. There's a lot of different names for the same thing, but in end, it's just one big equation. Okay, so this is going to be the equation for the unpaid balance, outstanding balance, payoff amount, whatever they want to call it. The amount that you have left to pay is equal to R times 1 minus 1 plus I raised to the negative n minus k divided by I. And you're going to see the inclusion of an extra letter K, similar to the letter that we had when we talked about deferred annuities. And that K represents the number of times that you paid, the number of payments you actually made. So this is after K payments have been made. I think it's actually pretty common for people to go into a 30-year mortgage and not complete that mortgage in that exact house. So it's really important for you to understand the way in which the loans are getting amortized. In particular, we're going to see that in the earlier stages of the loans, for the first half of it, you're actually paying more in the bank's interest charge than you are paying back your own principal, okay? So let's get right into an example that highlights that. Let's say that Mary has a mortgage, And the mortgage was originally for $300,000. That was the principal she borrowed. And that was at 3.6% compounded monthly. And it was a 30-year loan. So that was over 30 years. Okay? Now we're going to make a multi-step question. What I really want to know here is what's the unpaid balance after 1 year? Okay, so let's say she decides to jump into this house. She had to take out $300,000 to do it. And then after maybe 1 year, she wants to know, well, how far have I gone towards paying back my loan? What's the unpaid balance after 1 year? So you'd want to use the unpaid balance equation, but you can see that with the information that I have right now, I have $300,000, but that is not this A. Okay, keep in mind that when I put this A here, this is the payoff amount A. Alright, so that's not where the 300 goes. But I also don't have the R. So how am I supposed to solve out for this A, which is the unpaid balance after 1 year? First, I have to find the R. Okay, so if you're inside a question like this and they don't tell you what the R is, what the regular payment is, that's for you to find out first. So you must find the R first, and that way once you find the R, you can put it in this side of the equation along with K payments that have been made. In this case, she's done it for 1 year, so she's made 12 payments, and that's going to spit out the unpaid balance. Don't make the mistake of putting the $300,000 inside the payoff amount. Okay, so we must find the R first, and then we'll go back to the unpaid balance equation, and we'll use the R on the right-hand side there in order to spit out the unpaid balance. Okay, so let's do this first. Find the R. And that's going to require us to use the amortization formula, which is just the present value of an annuity. Solve for the R. The $300,000 principal goes there. The periodic interest rate, 036 divided by 12 on top, 1 minus 1 plus 036 divided by 12 here, all raised to the negative 30 times 12. That's the number of payments. Okay, and keep in mind, I'm just doing this as part of the process so I can use the other formula. So once you crunch through that, then you're going to see that Mary has been paying monthly payments of $1,363.94. Okay, that's what she pays every month. All right, now we can go and find the unpaid balance after 1 year by using the other equation that I presented. Okay, now it's time for that. So we're going to go to unpaid balance. And it's after 1 year. And you have to transfer that into K is equal to 12 payments. K is the number of payments that have been made. Okay, so remember, that's in terms of the number of periods, not the number of years. And so for that question, now we're going to have to say A, which is the payoff amount, is the amount that she's been paying every month, multiplied by all that, and that periodic interest rate was 0.003. You probably saw that already while you were trying out the other problem. And notice that this is where I have to enter the K right here, because inside the equation's formulation it was negative n minus K. So I have negative 360 minus 12 up there, and then I'm dividing that off by 0.003. Close it off, and then I get the unpaid balance $294,304.84. Okay, so what am I getting with this number here? This is the amount of principal that's left over after she's already been amortizing or paying off that loan for 1 year. That seems like quite a lot, doesn't it? Because she's actually paying almost $1,400 a month. She paid 12 of these. How much money did she cut off of that $300,000 loan? Only $6,000? So let's calculate how much of this money went towards her principal and how much of this money actually just went towards the interest charge. That's the real lesson for this part of the lecture. Okay, so let's calculate the total paid in 1 year. Okay, so over 1 year, let's say she paid $1,363.94 times 12 payments of that. So she paid in total $16,000, $376.28. That's 12 payments of her monthly payment amount, right? Okay, well, let's see how much interest was paid. How much, first of all, let's see how much principal was paid off. Okay, let's see. Well, she started with a $300,000 loan, and now the unpaid balance after 1 year is that equation you see right there. Okay, so the amount that she actually paid off of her principal was $5,659.16. The amount that she paid off her principal was under $6,000, but she gave the bank $16,000. Where did that other money go? That's just the amount that went towards principal. Oh, sorry, that went to interest charge. The amount that went to interest charge was the difference between those two numbers, so the total amount she paid, subtracting off the amount that went towards her principal. So the total amount that went to interest, $10,708.12, just towards the principal. Sorry, I keep saying that, just towards the interest, okay? So really what happened was the bank got almost $11,000 that year from poor Mary. She only paid off about $5,500 on her loan. And that's a big loan to pay off, okay? Is this actually happening every single year to poor Mary? Let's try to answer this question again, not for the very first year, but for the 21st year, okay? So 2/3 of the way into the loan, let's compare that with the amount of interest paid in just the first year. Remember, this is interest paid during the first year. You probably want to see that again because there was a lot of steps to that problem, and that's a very important question to be able to answer. So let's run through that again for during the 21st year. Let's ask how much interest was paid during the 21st year. Okay, so you notice that in order to answer the question of how much interest I paid during a given year, I had to first find how much principal was paid during that same year, and then subtract that off from the over $16,000 I'm paying every single year. Okay, so this amount does not change year to year. This is the same every year. Is that I have to make this amount of payment and I have to do it 12 times a year. So every single year I'm paying $16,000. In my first year, $10,000 went towards interest. I wonder about my 21st year. So first I need to find the payoff amount, or the unpaid balance, I should say. Unpaid balances for after 20 years and after 21 years. Okay, so first, find the unpaid balances after 20 years and after 21 years. Okay, the reason that I have to find these two unpaid balances is so that I can take the difference between them, and when I take the difference between them, that's going to be how much money went to the principal inside of the 21st year. This is how much money went to the principal during the 21st year. So during the 21st year is the difference between the unpaid balances after 20 years and after 21 years. Okay? Now I'm not going to do these ones completely out, but what you want to do, and you should definitely check that you can do this, is that you're going to apply the unpaid balance equation, and you just have different values for K. Okay? So these are both use the unpaid balance equation that I had on the board there before. Okay, and the 20 years one uses K is equal to 20 years times 12 times a year, which is 240. And then the 21 year one uses K is equal to 21 years times 21, which is 252. Okay, and then the difference between them is how much principal I paid in the 21st year. Alright, so let me write that down, and I'll just keep those little answers on the board so we can compare them to what's going to happen in the 21st year. Okay, so once again, take the unpaid balance equation that I had up there before and just apply it with these different values of K. Alright, so the first value you should get for unpaid balance, sorry about that, unpaid balance after 20 years, you should get 137,279 and 46 cents. And then after 21 years, we would expect that to go down a little bit, and it does 125,663 and 83 cents. Okay, so go ahead and make sure that you can get those values, understanding that this is the amount of unpaid principal that Mary has left to pay after paying us for a certain amount of years. Okay, so now let's take the difference between those. So the difference, which means subtract one from the other, is that you're going to get 11615 and 63. Okay, already you might be starting to see that there's a difference here, because this difference represents how much money went to the principal during the 21st year. And you can see that during the 21st year, over $11,000 went toward the principal. This is the same every year. She's going to pay the same monthly charge 12 times a year, every single one of those 30 years. And so when we take the amount that she's paid in, and this time subtract this large amount that went towards principal, we're going to see that the amount that goes toward interest is $4,751.65. Okay? So this number I've circled here is the amount of money that went towards interest in the 21st year. Over here, this is the amount of money that went toward interest in the first year. Okay? So these things that I circled are the amount that went towards interest in the first year, and this is going to be for the 21st year. I'll just write that. 21st year. And you can see that actually things are getting a lot better for Mary as time moves along on the mortgage, because in the first year she had to pay over $10,000, almost $11,000 just in interest charges, just for the bank. But in the 21st year, she actually paid less than $5,000 in the interest charge. Okay? So there's a major difference over time. And the reason for that difference is because the yearly interest that they charge you is calculated off of how much unpaid balance you have left. Okay, keep in mind that when we calculated the unpaid balance after 1 year, the unpaid balance after 1 year, I'll just write it up here, after 1 year, that was 294,340 and 84. Okay, so after 1 year, she still has almost $300,000 to pay. And when they calculate how much interest they're going to charge, they calculate it as a proportion of the unpaid balance. That's why it came out so high. But then later, when the unpaid balance is much lower, the amount of interest that they're allowed to charge is much lower. Okay? Let me draw you a little chart which shows you the proportion of payment, of each monthly payment going toward the principal versus interest. Okay, so let me just draw you a little chart, which is to say that this is the years, and we have to pay all the way to 30 years. We have this many years to pay off the loan, and this is my monthly payment. Okay, and your monthly payment is always the same exact thing. Okay, so every single month of every single year, your monthly payment is the exact same thing. But what's changing over time is the proportion of that payment that goes towards the principal versus the amount that goes towards the interest. Okay, so interest is bad. But when you're first starting to amortize a loan, you're mostly paying back money towards interest. Then as time goes by, try to draw it perfect because it has kind of an exponential form to it. It goes down like that. The proportion of the payment that's going towards the principal in the first year is very small, and then eventually it gets much higher. Okay, so this is actually a typical graph, and if you use the internet and you search for like an amortization graph on the internet, you will see a very similar couple of lines here, where in the very beginning, like for instance, this was year one, year number one, most of your money here is going towards interest charge. Very little of your money is going towards your principal repayment. Now once you get further along, like here we were in the 20th year or so, more of your money is going towards your principal repayment, less of your money is going towards your interest charge. That's what happens over time. Okay, so this is your good money that's going towards your principal repayment, and this is the bad money that's just going towards the interest charge. That's just the money that the bank is getting. Alright, actually if you look it up for a typical mortgage, it takes about 18.5 years. So you may wonder, like, when's the crossing point? When am I paying the same amount of money towards my interest charge as I am towards my principal? This takes about 18.5 years. Okay, so it takes quite a long time for you to actually be in the green here, where you're paying back your principal as opposed to your interest charge. It's a very ugly business getting into a mortgage, unfortunately, and you really want to keep that in mind, because what it says is that if you jump into a mortgage and then you just jump out a couple of years later, all you did was pay the bank a bunch of money. You didn't actually make money, you didn't really pay yourself. This is the good part where you're paying yourself. The beginnings of a long-term loan is the bad part, where most of your money is just going to go towards the bank's interest fee. And if you don't complete the process, and then you have to somehow return the unpaid balance, you're really going to lose a lot of money in interest charge if you haven't gone far enough into the loan. Okay, that's a very important lesson. I'd like to conclude this lecture with one more really good and classic lesson, which is along the same lines. What's the difference between a 30-year and a 15-year mortgage? Now, this isn't a joke. I wish I had a good punchline for you, but really I just want to know, if I choose to take out a 15-year mortgage instead of a 30-year one, is that going to cost me a lot more? How much money will I save? How much more will my monthly charge be? So I did a little comparison for current prices right now, and I live in Olympia, Washington, and so I looked up the current median home price around where I live, which is for Olympia, Washington, and the current median home price was $237,100. Okay, so let's say I want to purchase a home that's in that range, and what I want to do is I also looked up some current mortgage rates, some actual mortgage offerings from the internet. So here's some current mortgage offerings. And what I did was I looked up a 15-year one versus a 30-year one. And the 15-year one had a 3.125% APR, and the 30-year one had a 4.0% APR, and these were both compounded monthly. Okay, usually when you talk about mortgages for home ownership, it's typically compounded monthly. Okay, so these are both compounded monthly. So some questions I have for myself were, does it really matter which one I get into? Which one is going to have the cheaper monthly payment? That's right, the 30-year one that takes longer to pay back is going to have the cheaper monthly payment. Which one is going to end up me paying less in interest? This one is the one that's going to pay less in interest. Okay, so really, how do those compare with the actual numbers? Let's calculate. I know one's bigger and one's smaller than the other, but let's calculate the actual numbers. First question I have for you is that if I know that the 30-year mortgage is going to have a lower monthly charge, this one's going to have a lower, this one has lower monthly charge, okay, but this one has lower total interest paid. I know this one has a lower monthly charge, but because I cut the time in half on the 15-year, is that going to double my monthly charge? Am I going to have to pay twice as much a month if I choose this one? That's my first question. So let's compare what are the monthly charges on each. And I think you guys are ready to answer this question, so you should definitely try with the equations that you have already in front of you. What are the monthly charges on the 15-year versus on the 30-year? Go ahead and pause the video and try to calculate this out. Okay, so on the 15-year, let's see. Well, I did the 30-year first. I used the amortization equation, present value equation. And so I used the rate of 0.4 divided by monthly rate of 12, 1 minus 1 plus 0.04 over 12, and I'm going to raise that up to the negative 360 because I have to pay that 360 times. And then what I got there was $954 and 83 cents. Okay, so if I go with the 30-year mortgage, my monthly payment is under $1,000. That sounds very reasonable to me. If I went with the 15-year, would this double because it got cut in half, time got cut in half? So hopefully you tried that out too. Here we're going to have the same principal amount that I borrowed, and then I'm going to do 0.03125 divided by 12, 1 minus 1 plus 03125 over 12. And this one is raised to the negative 180. Excuse me there. Okay, this one's going to be raised to the negative 180 because it's a 15-year. Actually, one thing that I forgot to mention, I'm sorry I didn't put this earlier. You guys probably had a hard time answering this without that. But because the median home price was this, I just said I wanted to borrow $200,000 just to make it even. So sorry about that because you probably did it with that number. And keep in mind that every house you purchase usually has to come with a down payment too. And so I wanted only to borrow, principal of $200,000. Okay, so that's why I had the $200,000 there. I'm sorry I didn't mention that earlier, but if you redo it in both cases with a principal of just $200,000, then you got the $954.83 over there, and then this for the 15-year one, you should have got $1,393 and 22 cents. Versus this. This is very interesting to me because if I took this number and doubled it, I would get $1,900, almost $2,000, but this is nowhere near that. This is actually only about 45% more, 46% more of a payment than this one is. See, it didn't go up by that much, but I was able to pay it off in half the time. So although this one has a lower monthly charge, it is not half as much as this monthly charge. It is not. This one is only slightly bigger. And then the other question is, what's the total interest paid in both cases? So let's go into that. And that part should really make you appreciate the extra effort that it takes to pay off a 15-year mortgage instead of 30. Well, it's not too much more over there. Let's go into the total interest paid total. Okay, so let's do it for the 15-year one, and we'll do it for the 30-year one. And in both cases, the situation is the same. You're going to say, how much total money did I put in? In the 15-year one, you put $1,393 and 22 cents times 180 payments. Okay, so this one is 15 times 12, 180 payments. 30-year one, I put $954 and 83, and I had to do that 360 times. Okay, so let's first compare how much money I paid in each case. The total money I ended up paying on this mortgage was pretty darn big. The total money I ended up paying on this mortgage, not nearly as bad. Not nearly as bad. So if you think you can afford this easily, and it might be a little bit harder to afford this, keep in mind that after I subtract off the $200,000 principal in each case, keep in mind that you're going to be saving huge amounts of interest paid. Because in this case, on the 30-year mortgage, you paid so much money you could have almost bought a new house. And the 15-year mortgage, you could have only almost bought a new car. Okay, look at that. This one is a huge amount of interest paid. This one is not nearly as much interest paid. And that's what happens to that extra money. That's why this didn't get doubled. It only went up by 46% because where did all that extra money go? you didn't have to pay it to the bank. So you got to keep more of your hard-earned money. So the lesson here is that you should pay off a loan as soon as possible.